This is an example of solving a quadratic equation by factoring. We're going to use the zero product property in order to solve this. So a quadratic equation is an equation of the form ax squared plus bx plus c equals 0. We're looking for x-intercepts, so normally we would have that y is equivalent to ax squared plus bx plus c equals 0, but we set y equal to 0 to find where x crosses, or pardon me, where the graph crosses the x-axis. So we want to recognize that we have a quadratic by seeing that we have a squared term, a linear term, and a constant term. So if we just move the constant term over to the left-hand side, we'll reveal the quadratic. 3x squared minus 2x minus 5 is equal to 0. And then we can solve it by factoring. If it's factorable, not all of them are, it will factor into two binomials. We're lucky because the leading coefficient is prime and the constant term is prime. And there's only one way that can happen, is that you have 3x times x to get 3x squared, and you have 5 times 1 to get 5. So now we just need to see if we've gotten them in the right places. So we'll test it, right? So this is kind of a guess and check factoring method. So 3x times x will give us our 3x squared. And then between 3x times 1 and 5 times x, we have a 3x and a 5x. Between the two, we can definitely get a 2x. If we had them reversed, we would see that they were in the wrong position. And I tend to just guess them in the right position now. But we would see that we have 3 times 5 is 15, and 1 times x is 1. And between 15x and 1x, no matter what we do, we're not going to get a negative 2. So we would say, oh, let's try them in the reverse position and see if that'll work. And we saw that it did. 3x times x gives us 3x squared, 3x, and 5x. If we have one of them negative and one positive, we'll get 2, and we'll get a negative 5 when we multiply them. So we want the larger one to be negative so that the result of our summation is negative. So we'll make the 5x negative. And now we just make sure that this is indeed our factorization. So we want to test it by multiplying it back through and making sure it works. 3x squared plus 3x minus 5x minus 5 will give us 3x squared minus 2x minus 5, just like we wanted. We want to make sure that those signs all match, that the signs match. So now that we're here, we can use the zero product property by stating that 3x minus 5 could be 0, x plus 1 could be 0. Therefore, 3x equals 5, and x is 5/3, where we subtract the 1 over and just see that x is negative 1. And these are the two solutions to our quadratic equation. 3x squared minus 2x minus 5 equals 0. So these are the zeros, they're the roots, they're the x-intercepts.